On this episode of Coding 101, it's a wild card interview with Steve Gibson. He's going to give you 46 years of programming experience.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by Squarespace. Creating and editing your website is easier than ever using their redesigned interface, Squarespace 7, which includes integrations with Getty Images and Google Apps, new templates, and a developer platform. Try the new Squarespace at squarespace.com and enter offer code C101 at checkout to get 10% off. And by lynda.com. Invest in yourself for 2015. Lynda.com has thousands of courses to help you learn new tech, business, and creative skills. For a free 10-day trial, visit lynda.com/C101. That's lynda.com/C101. Hello and welcome to Coding 101. It's the Twitch show where we let you into the wonderful world of the Code Monkey. I'm Father Robert Ballecer, the digital Jesuit. Coding 101 is a place for novices, intermediate, and expert programmers to gather and talk about the wonderful things that happen in our field. Joining us today on this wildcard episode is Mr. Steve Gibson from Gibson Research. Steve, thank you very much for coming on to the show.
Padre, great to be here and with you today. Yeah.
Of course, we know you. If you're a member of the Twit Army, we know that you're part of security now. You are the security guru of the Twit TV network. I've actually had you on Padre's Corner, and now we get a chance to talk to you because you have a lot of experience in the programming world. But before we get into your tips, because you want to share your experience, you want to share the things that new programmers need in order to survive in this field, I want to talk about how you got to be the geek that you are today. Where did this all start, this love for technology?
Okay, so I think that the technology began for me, I mean, at an age before I can remember, because I do not remember being 4 years old, but I have a photograph that helps me know what was going on when I was 4 years old. My dad took a picture of me sitting at a picnic table that we had in the backyard of our home. It was up in Orinda, California, which is on the other side of the Berkeley Hills in Northern California, where I started growing up. And before me was a piece of plywood with an old-fashioned red sort of square with its edges cut off, 6-volt dry cell battery with the two terminals, the screw terminals, one in the center and one off to the side, and ceramic base screw-in light bulb bases and ceramic knife switches, which was electricity back then. And this was not something that my father was pushing on me. Something about it fascinated me. That, like, why do I have to complete the circuit, so to speak? Why can't I just have one wire that goes from the battery, which apparently is where the juice comes from, over to the light bulb, and then it will light up? No, it doesn't work that way. And, and here's this knife switch where, you could see how the switching action worked as the blade, made contact with the other side. So before I was 5 years old, from the date on the back of the slide that I have showing me at that age, I was wiring things. I just had to. It fascinated me. And then, of course, there was the record player and the vacuum cleaner and the iron and other electrical appliances. And I took those apart, had to figure out how they worked. And in fact, at one point, my disassembly was becoming so destructive that my father decided, okay, we need to feed this somehow in a means that will be less destructive to the household because, mom would go in to get the vacuum cleaner and she'd try to pick it up and it would fall apart in pieces because putting things back together always was much less interesting to me at that point than taking them apart. And so not far from us was Alameda, which was a major shipyard for the military at the time. And they were decommissioning ships and pulling or retrofitting them and upgrading them. But they were, in any event, pulling equipment off of aircraft carriers and battleships and things. And so what sprung up around this naval shipyard were war surplus stores. And while, there were, gas masks and canisters and that kind of stuff, there was also this wealth of electronics. And I remember well that it was all sort of nameless stuff, radar sets and radio equipment and sonars and all the stuff that you would expect to find on a battleship back in 1960, since I was born in 55, so 60, I would have been about 5 years old. The way you bought this was not what it was, but how much it weighed. And they had fish hooks hanging from a rafter. And so we'd, hang this thing on this fish scale and the dial would spin around 5 times and come to rest somewhere. And Dad would pay, a small amount of money comparatively for this. And we'd stick it in the trunk and take it home. And I remember we had a 2-car garage. He'd pull both cars out and stick this big hunk of something in the middle of the garage with his toolbox next to it and say, okay, Stevie, take it apart, tear it apart. And I would just hungrily plow into this thing, noticing how the knobs had set screws on them that kept them on, and how the shafts penetrated through the front panel and then were extended way back to the end where there was a potentiometer that had, for some reason, 3 terminals on it. And I would, someday come to understand why that was the case. And what Dad, many, many, many years later said was that his motive for that, aside from giving me something that, I could disassemble without upsetting Mom, he said that I was in his plan was that I would be deliberately internalizing the best engineering of the United States that had gone into producing this equipment. And even though I was taking it apart, I was noticing in the process how it went together. And as it turns out, whether that was actually what was involved or not, I did at some point switch over from disassembling things that other people had created to imagining and then creating things of my own. So, that was the start. It was hardware.
Steve, when I had you on Padres Corner, the thing that stuck with me the most was how much your father had to do with your passion for everything, not just electronics, not just for programming, but just for how things work. In the maker community, you can see it. There are some people who become incredibly proficient at figuring out how to make stuff do something. But then there's the next level up, and that's people who want to know why that procedure, that process makes it do something. And those are ultimately the people who are going to be able to get in there and change it around. I want your input on the analog between that and the software world. One of the questions that we ask a lot of our wildcard guests is whether or not it's easy just to jump into programming. And by that I mean there are some people who think if I study enough, if I memorize enough stuff, if I do things enough times, that I will become, quote unquote, a programmer. And I think there's a great analog here, which is you can become a person who knows all the vocabulary and a person who knows the syntax, but unless you've got that spark of curiosity that makes you want to dig through, you won't be a programmer. You might be a coder, but not a programmer.
A perfect example of that is a couple years ago, a very good acquaintance of mine from Starbucks had her son in high school, and she herself is an elementary science teacher. He was in high school, and he thought, hey, there's a computer programming class. I'm going to take that. And so, she, her name is Lisa, knowing my passion for software, said, hey, Alex is taking a class in computer programming. And I thought that was, great. I mean, he was sort of your contemporary kid who didn't really have a passion, didn't have a direction. I remember, for example, for me, when my gang in high school all had to decide what we were going to be at some point, there was no question what I was going to be. I was going to be, something to do with computers. The major that UC Berkeley had, which was my major, was EECS, Electrical Engineering and Computer Science. They understood how those things were related to each other, which I was really glad for, because it didn't force you to either be hardware only or software only. It was a program that pulled it all together. But my peers in high school, were they like, well, I have to choose now what I'm going to be? So, there was just sort of no direction. And I think that's maybe even more the case today. So when Alex demonstrated or manifested some interest in computers, it was like, hey, cool. And I had some texts that I thought might be useful, which I gave to his mom to give to him. The point is that he got to a certain point and he decided it wasn't for him. And when I asked his mom what had happened, she'd asked him. And so she actually knew. Unfortunately, due to the way that the curriculum was being taught, and I'll put that in air quotes, he would get to a point in an assignment where something didn't work and he would not know how to fix it, because basically they were teaching computer science by copy and pasting. They were trying to cram, I think it was both Java and C were the two languages that were in this, maybe it was a half a year or maybe it was a year-long course, but there was, the problem is that the kids are all seeing video games and saying, I want to create one of those. And so there's tremendous pressure on the curriculum designers to produce a result. And the fact is, you could easily spend a year on fundamentals of what's actually going on. Like, what is binary? What is octal? What is hex? How do you add, how does a computer add numbers? And what's the representation of those? And I could design easily a year-long computer programming curriculum where at the end of that, you would never have written one program, or maybe some simple, like, loops and jumps and conditionals. I mean, but what you would have at the end of that was an absolute understanding of what's really going on. And on that foundation, then you could easily layer any language, because that, you would really get what you were doing. But instead, this curriculum was in such a hurry to give them something that did something, that at no point did they ever deeply understand what it was that they were, basically cribbing from something else. And when it broke, when it didn't function, they had no, because they didn't really know where it came from. They didn't know how to back out of the problem. Basically, Alex had no concept of debugging. That is, what to do when it doesn't work, because this sort of came to him as whole cloth. And it was like, as long as, the pieces fit perfectly, he could push a button and, make something count up. But if it didn't, he didn't know what to do. And basically, and so I got a sense from that for the unfortunate way that programming is being taught today. Another example is we have one surviving electronics retailer here in Southern California, a place called Marvac. And, that's where I go when I need something immediately that I can't, have DigiKey or Mauser send me through the internet. So I was there looking for something specific. I think I was asking for a certain a 1N914 diode or something, and the guy said okay, and he goes back and was trying to find it. There was another gentleman next to me who it turns out was a small business owner whose business was something to do with electronics, and we just sort of struck up a conversation, and somehow we got talking about sort of the nature. I mean, he was about my age, so in his 50s, and absolutely understood electronics. And I guess I was talking about maybe software people I had hired. He started talking about hardware people and how out of university he was interviewing, kids who similarly didn't really understand what it was they had just learned. He would, like, as part of his hiring test, he would say, draw me a multi-stable multi-vibrator, and, he and I could both do that. Basically, it's two inverters cross-coupled with some capacitors in order to make it go. But none of the kids that came out of engineering with a fresh degree, still where the ink was still wet, could answer that question. And it turns out that unless he set them up at a workstation with all of the same software helpers, the same software, IDEs and CAD programs, and exactly what they knew how to operate and how to, like, select from components from menus and drag them in and then, look for somewhere about how to wire it up from some application notes. That was the world that they understood today. Again, lacking the basic understanding in the fundamentals of where this stuff came from. They were operating several levels of abstraction above that. And I guess I understand that the world has become abstracted to the point where nobody really is wiring things up with resistors and diodes and transistors anymore. I mean, I am. I actually have a little project that I've been working on that is that. But that knowledge, it's like it's too expensive to acquire that knowledge today. So the world tries to sort of just say, oh, don't worry about how that works. That's, here's a chip with wires, and yeah, it's got that stuff inside it, but hopefully you'll never really need to understand that. Just, wire this thing up, and it understands how to do the things you don't, with it, it's no longer cost effective for you to know. And unfortunately, the same thing has happened in code. It's due to the nature of the system. Everybody's in a hurry. No one has time. You just don't need to know that. And one of the things that I noticed when I was hiring programmers, I went through a phase where I was trying to grow the company. I had SpinRite already in the world, and I had some ideas for other stuff I wanted to do. But I was now running a company, and unfortunately, I learned that meant I no longer could do any coding. I had to manage the coders. And I realized that the other one guy who I was ever lucky enough to hire who was actually good was good because he too had been a hobbyist. He had been messing with this stuff way before there were any classes that he could take. I remember when I got to high school and there was actually a class in electronics. It was like, holy crap, you're kidding me. I couldn't believe I could take a class in something I had a passion for and I've been working with for years. And it just turned out, I created 2 additional years of curriculum in that high school that went district wide after I left in digital electronics, because the old Navy instructor that the high school had didn't know digital. He knew analog, but of course the world was going digital. And so I ended up creating curriculum for the high school that the district ended up replicating throughout all the high schools in the area, because this was just my passion. But so I guess the best way to say this is that the stuff we're doing today with all facets of computers, both the hardware and the software, is built upon a deep and rich foundation. And you ignore that at your danger. I mean, and potentially ultimately at your cost. You can try not to know that stuff, but some part of you, I think, will always be a little anxious because you know you don't understand that, and it might come back and bite you. And the trouble is that there isn't a shortcut. There's no short circuit. There is, and the other problem is this stuff is beginning to sort of leave. I still have a book on programming the VGA, the video graphics adapter of the original IBM, and I needed it for when I was moving from SpinRite 5 to SpinRite 6 10 years ago. I have that book, but you can't find them anymore. And even online, that sort of pre-internet knowledge, which hasn't moved online. So the danger, of course, is that some of this knowledge is beginning to die with the people who have it, who themselves are just biologically dying as it becomes, as it moves deeper into history.
We're speaking about the foundation of knowledge with Steve Gibson, the security guru of Twit TV. Steve, when we come back, I'd love to continue on that vein of thought just a little bit, to talk about how education has changed a little bit. Actually, we've hit this challenge in Coding 101 in a lot of our educational programming here on Twit TV. You spoke to it very eloquently, that the idea of knowledge-based learning versus goal-based learning. And, the pendulum swings back and forth all the time. But I think you're right. I think we've reached that layer of abstraction where we may want to pull back and say, do we teach enough foundational knowledge for people to be able to strip off those top layers of abstraction and still have something to work with? But before we get there, I want to take some time to talk about the first sponsor of this episode of Coding 101, and it's Squarespace. Now, if you watch Twit TV, you know what Squarespace is. Squarespace is your one-stop shop for all your hosting needs. And right now, they've even got one better with a brand new interface, the newest version of their platform, Squarespace 7. It's a completely redesigned interface that makes it easier to create your own professional website or online portfolio. Now, I've used Squarespace in the past because I deal with a lot of organizations that don't have a lot of technical knowledge, and I need to give them something where they just publish content. They want to put out a portfolio of their events, they can do that. Do they want to just put out an explanation of their mission statement? They can do that. Do they just want a place where people can meet and figure out what they want to do for their organization? They can do that. But this is what Squarespace 7 gives you. Live editing on one screen. Now, if you've ever had to do any sort of WYSIWYG programming, you know what a pain it can be. Edit, preview, edit, preview, edit, preview, going back and forth to figure out what you're trying to do. Well, with Squarespace 7, you don't have to do that. It tells you in real time what your edits will look like. It's a fantastic feature that comes with 7. Now, the developer platform is used by some of the world's top digital agencies. And if you're a developer, you can customize your site exactly the way that you want. It's not just the template, it's the template plus the little extra something that you want to give it. They give you over 14 new designs to choose from, giving you over 30 in its entirety. And their cover pages is new with Squarespace 7, which lets you choose from 10 new templates. And you can add these to any existing Squarespace site, again, to give you that little extra something that sets you apart from the rest. Now, if you're worried about licensing, don't worry about it with Squarespace 7 because they give you access to Getty images. For just $10 each, you can pick from thousands of professional Getty images and put them automatically into your Squarespace asset box, which means you don't have to worry about licensing. You don't have to worry about getting dinged for using a photo that you weren't supposed to. It's all part of the package. They also include e-commerce for all subscription plan levels, so you can add a storefront to any site and instantly accept payments. And they now have Google Docs integration, which works with Gmail, Google Docs, Sheets, Drive, and Calendar. Plus, Squarespace 7 can easily link branded email accounts to your domain, which means you don't have to have generic name at gmail.com. It can be you@you.net. Now, with the Portfolio, Note, Metric, and Blog mobile apps, you can make changes from anywhere. This is part of their 24/7 access to your content. No matter what device you're using, no matter where you are, as long as you're connected to the internet, you have control over your content. That just makes it incredibly easy to use. Now, if you need help, they've got live chat and email support 24 hours a day, 7 days a week. Plus, there are self-help articles and video workshops to browse at your leisure. And all of this starts at just $8 a month. And Squarespace takes care of hosting, so you don't have to. Plus, you get a free domain name if you sign up for a year. So here's what we want you to do. We want you to start a free 2-week trial with no credit card required and start building your website or presence today. When you decide to sign up for Squarespace, make sure to use the offer code C101 to get 10% off and to show your support for Coding 101. To begin using Squarespace 7, existing customers can go to the Settings tab to activate all the new features. And we thank Squarespace for their support of Coding 101. Squarespace. Start here. Go anywhere. We're here with Steve Gibson from GRC. He is our security guru and also a man about programming. Steve, let's go back into that because I want to tease out a bit more of your knowledge about learning the foundations. When we started Coding 101, we wanted to do exactly that approach. We wanted to give people the foundations that could translate between all the languages. And what we found was that there was an initial boom of interest, but then people just started dropping off. People didn't really want the foundational knowledge. They wanted the project knowledge, and that's more or less what we've shifted into now. We'll have a little bit of a project so people know what they're building, and they can, at the end, say, I did this. But as you mentioned, that can be an issue because if you don't have the foundational understanding of why those elements do what they do, it means that if something breaks, as one of the members of the chat room said, it's a lot of trouble for very little consequence at the end.
Right. And I guess, a platform like the Arduino is a perfect example of sort of a compromise. You're not actually dealing with the hardware and the true processor programming. That's been abstracted to, a basic like language where you say, oh, I want a delay for this long, and now, raise this input and lower that output and so forth. So that's sort of a compromise. I think that I guess if a person isn't curious, then there's not a way to impose curiosity. And someone may not be curious because they're unfortunately, there's no other way I can put this than that they're afraid of failing. And one of the things that these self-contained sort of meta solutions offer is a guarantee that you won't fail. I mean, they make it easy, to achieve something. And one of the, a famous statement is that, if you're not failing, then you're not trying. And so one of the things that a person has to become really comfortable with, I think, is being able to say, I don't know, I don't have the answer. And geeks tend to have a problem with that because they grow up sort of, the whole notion of being a geek or a nerd is, sort of that whole know-it-all persona. They're like the only computer literate person in the family. And so they sort of adopt this, oh yeah, I have all the answers, because they're sort of supposed to. But it's necessary. I mean, it is necessary to shed that and to be comfortable, if only with yourself. And the problem is, unfortunately, we tend to internalize who we are. And so it doesn't help you if it only has to be with yourself. You need to be able to be comfortable with not knowing and not having all the answers and being stumped and being willing to struggle and and to have I guess just to be able to be comfortable staying in that place for a while and teasing out an answer. And so, are you a person who enjoys puzzles? I love puzzles. I used to be a pain in the butt for my family at Christmas time. That sort of, I like the couple layers removed, the aunts and uncles who you don't see except over the holidays. And because what they knew they could give me that Stevie would love was a puzzle. And so they would go into the toy stores that we had back, in the 60s and say, okay, I've got this really annoying nephew who solves all the puzzles that we ever give him. So what's the latest and greatest puzzle? And so the point is that I enjoy being confronted with something I don't know and don't understand, a puzzle. And that's always been my nature. But I recognize that's not everybody's nature. Some people's personality they don't want a puzzle. They don't want to feel stupid. They don't want to feel like there's something they can't do or that someone's going to find out, because their personality, their identity is wrapped up in having all the answers. And so I don't know how you get from that position of comfort into what is going to be fundamentally uncomfortable. You need to be okay with that. You need to just, not know, because it's only if you get yourself there that then you can start to really find out. You can really, start to learn things that aren't already prepackaged and, pre-digested to make sure that, you succeed. Maybe you won't, but in not succeeding, you will learn things that you can't learn through any sort of a guaranteed prepackaged system.
Absolutely. Next week, we've actually got Mark Smith. He's one of my DEF CON friends. He'll be coming in, and we're doing a crossover between Coding 101 and Know-How, because he's an embedded systems programmer / electronics engineer. So he's going to show us how he takes embedded processors and actually turns it into something, and then we're going to program it. But he was on a panel with Lost, who is one of he's a genius at DEF CON, and he makes all the badges, and he's got embedded programming in his sleep. But on this panel, one of the things that they all kind of groaned about was when someone in the audience brought up the Arduino and how the Arduino has changed everything. And they all said the same thing. They said, okay, well, let's be clear. We're not hating on people who use the Arduino. The Arduino is actually a fantastic platform, and it gets a lot of people interested. That's all great. But you have to understand, we were doing what the Arduino is trying to do for decades. And that the Arduino is great because it's like a Lego set for people who want to get into that sort of making, that sort of DIYing. But there still needs you still need that person who makes the Legos in that shape. So if you don't have that person, and if you all become Arduino people and you all just color within the lines, then there will never be the next Arduino, and there will never be the next electronics kit that will perhaps inspire the next generation of electronic engineers and embedded system programmers. Let me ask you this. And since we're now heading into this territory where you're kind of laying down your 46 years of knowledge upon our audience, if there was somebody who is listening to this podcast and saying, well, I want the foundational knowledge and I want to know if I've got that proclivity to create like Steve Gibson, what's the advice that you'd want to give them?
Okay. I'm holding up here a little $10 circuit board that Texas Instruments sells called the Launchpad. The answer to your question is do something. The way to learn is by doing. And, that's for whatever reason, I got started at age 4 building and I've never stopped. And so I got probably, if nothing else, I got the sense that, hey, I can hook these wires up and with a battery has juice and the light bulb is not burned out, when I close this knife switch, that light is going to go on. And it did. And then I thought, hey, I like that. And then I got another light and hooked up the other side of the knife switch. And then I, got a doorbell and made it ring and so forth. The point is that you need to switch from being passive to being active. And you also need necessarily to cut yourself some slack. There's no hurry. There's no deadline. No one's going to grade you. This is not about achieving anything other than for yourself. What this little $10, I mean, it literally is $9.99. Shipping used to be free. Now they charge shipping. So, but for less than $20, this is a beautiful little chip sitting here in the middle. It's got a USB, a micro USB connector, and they provide the cable as part of it. And so this is bare bones. There's no code in here. There's no Arduino interpreter. This is a venerable chip. It's a 16-bit microcontroller or microcomputer, which I think is perfect. 32 bits is too many. 8 bits is not enough. 8 bits is a pain. And whereas 16 is sort of a sweet spot. It's beautifully designed. The IDEs, the integrated development environments are free for this. You download them from TI's site, and you can start programming. And so it's got a couple of little LEDs on it. It's got some push buttons, and you can get a start with something that is this chip is used in embedded applications. I love it because it is incredibly low power. So you can create things with it that you cannot create with the Arduino, where things like smoke alarms or IR sensors and all kinds of different things. But the point is, it doesn't have to be expensive of anything other than your time, and it will be a time sink. It will be unbelievably expensive of your time, but unfortunately, there's no way around that. So it costs nothing in dollars. It costs everything in hours, because it's hours of you fighting with the compiler. Why doesn't it like the syntax that I just entered? And scratching your head at why the program doesn't do what you expect. And for that's not many people's cup of tea. But there isn't a way of cheating that. There isn't a way around it. If what you want is to really gain an understanding of bits and how the add instruction works and a conditional jump and where all this stuff came from, then this is the way you get it. You get it by starting with something that is nothing and building something of your own from that. And it is not expensive in dollars, but it will burn up time. But if there's a passion, if you have that desire, then it's absolutely, within reach.
I think you absolutely have to have that. You have that passion to build something of your own. Every kit I've ever done, every project I've ever created, every circuit I've ever breadboarded has always reached that point where I could say, I could buy something for X a number of dollars
Yep.
and do way better than what I'm programming or creating right now. But there has to be that, well, but I want to finish this. This is mine. This is my version of it. And that might be better. And I may end up buying that for a permanent installation. But I want to see if this will actually work.
And it changes you. That's the point, is that, while you are doing something to it, it is doing something to you. You are changed when you come out the other end of that. One of the reasons that there's frustration is that it doesn't do what you think it's going to. Well, that's because what you think is wrong, and it's going to teach you what is right by you insisting on finding the answer. The answer is there. And so that's what's different. That's fundamentally what's different about being a hobbyist and being active rather than passive. If you're playing a video game, sure, you're discovering what the video game designers hid. You're figuring out the puzzle that they laid there for you. But you're not fundamentally changed. If you start with a project, as a builder, and you decide, I'm going to build this, and it involves a microcontroller, and you want to start at the beginning, then you don't know how to do that when you start. You, by definition, will know how when you end, because you will have learned. You will have figured it out. You will have solved more problems than you can even enumerate. There are more things you don't know than you can imagine. And that's the point. You don't know. But when you push this thing through, you will end up knowing, because you will have had to learn in order to solve this problem that you set yourself. And again, I get it that it's not for everyone. And the Arduino certainly has a place, because for many places, you don't care about the details of how it operates, because what you want is to treat it like a macro block. It's just going to be this black box that you give it some stimulus, and it gives you some efferent and afferent inputs and outputs. And if that's what you want, if that's what you need, fine. Don't ask or expect more. But if you are interested in understanding more, it is possible to get that, but not quickly, because there's a lot to understand.
We're speaking with Steve Gibson, the security guru at Twit TV. We'll be right back for some final words of wisdom to all you programmers out there. But first, let's go ahead and take a moment to thank the second sponsor of this episode of Coding 101. It's lynda.com. What is lynda.com? Well, unsurprisingly, lynda.com is the place to go on the internet when you need knowledge. And hey, you know what? It's 2015. Why are you learning the same old way? Do something good for yourself. Kickstart your new year and challenge yourself to learn something with Lynda with a free 10-day trial. Now, lynda.com is used by millions of people around the world and has over 4,500 courses on topics like web development, photography, visual design and business, as well as software training like Excel, WordPress, and Photoshop. All their courses are taught by experts, and new courses are added to the site each and every single week. Oh, what is your plan for 2015? Do you want to improve your job skills to ask your boss for a raise, or make yourself more marketable to find a new job? Maybe you want to work on that foundational knowledge that Steve is talking about. Well, with a lynda.com account, you can. Some of the courses and videos that I recommend are building mobile apps with Parse and Swift, installing Apache, MySQL, and PHP, up and running with the Google Cloud Platform, and Code Clinic. It's an innovative series where each month lynda.com issues a code challenge, and authors share their solutions using a variety of different programming languages. If you've got a passion for learning, if you've got a passion for figuring out all the different ways that you can solve a problem, Lynda wants to help you do that. Now, Do something good for yourself in 2015 and sign up for a free 10-day trial to lynda.com by visiting lynda.com/C101. With your membership, you'll get unlimited access to every course on lynda.com, which includes access on your iOS and Android devices, plus new courses as they're added each week. That's lynda.com/C101, lynda.com/C101 to try it free for 10 days. Go ahead. I challenge you to learn something new in 2015, and we thank Lynda for their support of Coding 101. Steve, final words here. So we've talked a lot about what we should be learning and how we should approach coding and programming and figuring out how things work. But digging back again into your 46 years of computer programming experience and knowing that you're one of the few people, at least that I know, who can do assembly well, what is something that you want that young novice to get into? You already showed them the board that they should get so that they could pique their curiosity, but what other tidbits of wisdom can you give them?
I guess the only thing that really comes to mind is not being in a hurry. I think that that's one of the problems, is that we're all used to using very sophisticated subsystems and systems and tools that are amazingly empowering, and there's a shock which occurs when you realize, by looking at something that has like none of that, by this little guy where there's no assistance. It is a microcontroller. It's got EEPROM. So you're able to program it, and it's non-volatile. It's got RAM. It's got an amazing array of peripherals. I mean, it's a fun little chip. But the point is that there is because it is so low level, doing anything with it, making it do anything, is surprisingly difficult. And so there's like a reality shock that occurs where you realize, wow, I had no idea this would be this hard, because it's completely out of our experience. It's out of everyone's contemporary experience, where we're booting an operating system with phenomenal capabilities. We're running applications with phenomenal capabilities. It's a little bit like the example I drew with the guy that I bumped into at the electronics store, whose students he was hiring out of college couldn't do anything unless they were surrounded by these suites of tools that they had grown used to using while they were taking courses in college. Without them, it was like, they were standing there naked. They couldn't do anything without all of that support, without that massive support. So I guess the last thing I would say is, be prepared to be really surprised. I mean, to be sobered by what the reality is of what the actual underlying foundation is upon which we have built, because no one's experience of using stuff today can prepare you for that. And again, maybe it isn't for you. It is for me. I program today in assembly language. Squirrel, the Squirrel client that I have written is all in assembler. All of the code on my server that runs all the stuff that is there is all in assembler. That's the language that I prefer to use. I code rather quickly in it, because it turns out that when you code correctly, the language you're writing in doesn't make that big a difference. And we'll probably pick up on that topic with our next with my next visit to Coding 101.
Steve Gibson from Gibson Research at grc.com. It's the home of my favorite tool in the world. That's right. If you don't have SpinRite, I don't know what you're doing with your life. Steve, of course, SpinRite was written entirely in assembly. So
Yep.
you're
Still
a man
is.
who does what he preaches. Could you please tell the Coding 101 audience where they can find you on the internet other than grc.com?
So my company is Gibson Research Corporation, and I was on the net early enough to get those initials, grc.com. So that's where I hang out, and all my stuff. SpinRite is it's on the main menu. You see it when you go to grc.com. If you click that, it takes you to the SpinRite page. There's like a lot of information, lots of other utilities and stuff, and more all the time. So grc.com.
Steve, it is a pleasure, always a pleasure to speak with you, no matter what show it may be. A few of the people in the chat room figured out my plan. I'm trying to get you on every show that I host in some way, shape, or form, and I'm pretty sure I could do it. You've already been on Twiet. You've already been on Padres Corner. You've now been on Coding 101. I think it's pretty easy to get you on Before You Buy and Know How. So we'll get that done.
Cool.
Thank you very much for being with us.
Thanks, Padre.
Folks, don't forget that even though this is the end of this episode of Coding 101, you can find all of our episodes by going to our show page. Just drop by twit.tv/coding or C101. It'll all direct to the same place. You'll find all of our back episodes, including our modules. So if you want to know what we've been doing, if you want to know the projects that we've taken up, if you want to see our notes and our code base, you'll find it all right here. Also, we've got a Google Plus group. Just go ahead and go into Google Plus and look for the Coding 101 group. It's filled with newbies to programming, intermediate folk, and expert programmers. It's a great place to go if you want your questions answered by people who are actually working in the field. And don't forget, you can follow me on Twitter. Just jump to twitter.com/PadreSJ. That's at PadreSJ. Not only will you find out who we're going to be having on for every episode of Coding 101, but you'll find out what I'm doing in between episodes and between shows here on the Twit TV network, be it Coding 101, This Week in Enterprise Tech, Padres Corner, or this. Finally, I want to thank everyone who makes this show possible, to Lisa and Leo, who will keep the lights on for me, to my super TD, Brian, who has abandoned us. So if you could please jump onto Twitter at twitter.com/cranky_hippo, give him some grief, and tell them that his stand-in, who is Zach. Zach, do you have a camera on yourself at the moment? Yes, if you could, Zach, tell people who you are, because they're going to see more of you once we get rid of Cranky Hippo. Where do they find you?
Yes, you can find me on Twitter at Eskimo Zach. That's ESKIMOZACH. Thank you, Padre.
Thank you very much, Zach. And Cranky Hippo, yeah, I went there. Until next time, I'm Father Robert Ballecer, the digital Jesuit. End of line.